Hello there folks, here's a quick video today to teach you how to use the TURCK BL20-PG-EN-V3 and CoDeSys 3 to set it up to be a ModbusTCP Slave so that you can have some ModbusTCP Master device pulling the IO locally on. So we go over to our CoDeSys version 3 software here, and for instance I'm just going to start new, do new project. I'm going to click on standard project here, click OK, delete whatever I had here before, no big deal. Alright, I'm going to make sure that I'm using the TURCK BL20-PG ladder diagram, click OK. So here we have our environment. I happen to have a programmable gateway here, so I'm going to use it to build my system. So to go online, I'm going to double click on the device here. Right now I'm set up. This is the gateway comms within my PC, but I need to connect to the BL20. So I'm going to click the scan network here, and it's going to go out and find that particular device. Looks like I got one there. I'll click OK, and now I get a green diamond here, or green circle, means that's correct. I'm going to close that. Now that I've established communications to the BL20, I'm going to import all of the IO that's connected. Since I'm connected live, I'll do this. So I'm going to, over here, I'm going to right click on this local IO and come down here and click scan for devices. You can see here, folks, that this current rack happens to have, it looks like 8 digital input and 8 digital output as well. So that looks good. I'm going to click the copy all devices to my project. There we are. And now I've got those localized IO right here and right here. So this sets up my localized rack here, but I also want the BL20 to be a ModbusTCP Slave to allow some other things to talk to it. So to set up the slave driver, we're going to go over here on the left hand side, and we're going to go to the word Ethernet over here, double click on that, and we're going to tell it that it needs to use the interface for the BL20 gateway. So I'm going to click this button right here, and it brings up the IO that's out there, and this is the localized IP address of my BL20 rack. So I'm going to click OK. Now that sets up the comms there. I'm going to click status. Looks good, everything looks good here, but I'm going to add a driver under here. So over here on the left, I'm going to right click on this Ethernet, and I'm going to add a device here. Why is that phone ringing? Oops, hold on a second, guys. This. Yeah, it's probably some person. Anyway, so I'm going to go over here and I'm going to add a device right here. Click on Modbus device here, click add device. And now I should have, let me shrink this down. I now have the ModbusTCP Slave Driver here. And I want to point out to you guys that I've got a checkbox here on the timeout. I'm going to uncheck this timeout box, because what that does is if there's not continual traffic from the master, then your outputs are going to go to default state. So I'm going to uncheck that so it's not continually being pulled. I also want to point out to you guys that you can see here it has by default 10 registers set up for input for words in the holding registers. Also take note here that there's the input registers that it has 10 as well. Just so you guys know, the TURCK IO supports up to 1024 input words and 1024 output words for communications to and from a ModbusTCP Master. Again, that magical number is 1024 registers input, 1024 registers output. Okay, so I've got this set up here. If I go here, you can see that it's over. I've got inputs and I've got outputs, and this is an array of 10 words, index 0 through 9, and of course the outputs has got an array. So I'm a kind of guy who always likes to name things, so I'm going to click here and I'm going to call this MB_inputs, enter, and then for my output registers I'm going to call it MB_outputs, enter. Okay, I just declared those. All right. So my goal Let me just reiterate what my goal is, folks. My goal is to take the inputs from this here card and put it out on some Modbus registers such that a ModbusMaster somewhere else could see this I/O. So what I'm going to do, I'm going to double click on the PLC program. This is my ladder logic program. Move this over here. And this first slice has 8 digital inputs, or a byte of data. 1 byte, half a word, folks. Half a word is a byte. So I'm going to use a conversion here. I'm going to go over here to, let's see, is it other operators? Yes, right here, and there's a conversion under other operators. And watch this trick. I'm going to grab this conversion function block. I'm going to drag it out here, and I'm going to drop it right here where this green arrow is. Watch, I'm going to drop the green, boom. Now I get a rung here, okay? And what I'm going to do is I want to make this be the function byte to word, because I want to take this input byte here, and I want to send it out to the output byte here. So I'm going to click here on this triple dots, go to conversion operators, make this a little wider so you can see it, and I want to go down to byte to word conversion, byte to word. Hit OK. RedLion device here. And in RedLion, I've got under communications, just so you guys see what I'm doing here. I've got a protocol 1 ModbusTCP Master set up. I've got the localized IP address here of the BL20 rack. Notice I named it BL20_17. If I go to data tags here, start new here, data tags, I'm going to go ahead and create a new tag, and I'm going to call this one inputs. Okay, all of the input data from TURCK, all of the data that is over here, all these input data, these show up in the analog input registers within the Modbus world, or the 30,000 series registers. So back here, I'm going to hit the pull down on this inputs and go here to BL20, I'm going to use the analog inputs. This is totally different than the older TURCK 2.358. This is really different, folks. So it's going to go to the analog input register 30,001. Click OK. I'm going to make this guy an unsigned integer. This default integer, sometimes I don't like that, so I'm going to make it sure it's unsigned integer. I'm going to make it be a read-only because it's an input, and I'm going to go over here to display pages, and I'm going to see if I can put that tag on the screen. I'll drag it over here like this. Make this guy be a little bigger. Boom, boom, boom. Hold it. And so this should be my inputs, and I also might give it a border for green. All right, let me go ahead and download this to my localized HMI here. And then, you know what I forgot? I want you guys to see this. So I'm going to go turn on the web server. That way I can pull up the web page on my PC here. So I'll go ahead and download this to my HMI here. And then if I go open up, let's see what we got. Let's go here. So if we go, close these tabs here. We go right here and type in that localized IP address 192.168.1.17. Not 17, I'm sorry, the IP address of the HMI, which is .20. Click here. You're going to see there's my inputs on my screen. So if I turn on input number 0, there's number 1, bit number 1. There you go. And here's the next one. And if I turn on all three of those guys, you'll see that the same number. So right now I'm turning on all three. I guess I can't pull them up. Right. There we go. It's the same number that is over here in the ladder logic. So that's how easy it is to take inputs from your BL20 rack and have it display on a localized HMI. Okay. So the next thing I want to do is I want to go the opposite direction. I want to go from the HMI to my BL20 rack. So I'm going to go ahead and log out of my project. Right here, I logged out, and I'm going to do another conversion. So, because this time I'm going to take a word to a byte. So I'm going to go over here to my function blocks. Nope, other operators. I think it is. Shrink this down, and I'll drag this over into a next line down below. Okay, this one is going to be a function of word to byte because I'm going to get my data from the Modbus world and put it into a byte. So I'm going to go down and find a word to byte function here. Word to byte right here. Word. Let's see. Here we go. Word to byte. Click OK. Hit enter. That declares that. I'm going to make this guy always run here by putting a 1 there. Okay, now this time on this side, I'm going to use the Modbus holding registers here. So MB inputs, enter. And I also should point out to you folks, I should do :0 because of that problem we had earlier right here. We got to make it an array. But then over here, I want to turn on this output guy. So let me double check something. Look at here. I'm double clicked on my 8 output. %QX number 1, not word 0, but number 1. So I'm going to go back here to my program, and I'm going to put %Q for outputs, B number 1, enter. All right, let's go ahead and download this, see if it runs in our HMI here. We got no problems. We're running. That looks good. Okay. Now, if we go back, well, I'm sure we download to our BL20, I should say. So our goal is to take something from the HMI and have it fire localized IO. So I'm going to go over here to my HMI program. I'm going to create a new register here in data tags. I'm going to call this one outputs. And then I'm going to hit the pull down here and choose BL20. Everything in the output world, team, will map to the 40,001 series. So the inputs goes to 30,000 analog inputs. The outputs will go to the 40,001 and on up. So I'm going to go ahead and click OK, do unsigned integer, and I'm going to leave this one read and write because I want you to see it on the screen. So I'm going to go to display pages, drag this guy out here like this. I'll make this the same size as this one. Boom. I'll copy from all formatting from here. However, on this one, I need to make this guy be a data entry field. So this button here makes it data entry. And since it's something I'm going to write to, I'm going to change the border to red versus green, just in case we don't fill it. So I'll make it red like so. All right, let me download this to my localized HMI. And let's go back here to my CoDeSys so you can see it running. And how about our little browser? Let me make this small. Maybe small. I want you guys to be able to see this maybe at the same time, maybe not. Hold on here, team. All right, so if I click here and put in a number, say for instance, I enter number 1 in here. Notice you get a 1 here on the screen. I also see that on the localized slice, I also have a 1 there as well. So if I change this to number 7, for instance, I have turned on the first 3 outputs on that card. Output 0, 1, and 2. If I put in, for instance, number 15, or hexadecimal F, well, I guess number 15, now I'm turned on the first 4, and since this is 8-bit, I believe, if I put in number 255 here, the problem with the keyboard, team, is not improved. So now I've turned on all 8 of my outputs on that particular slice, which is pretty cool. So that's how easy it is, team, to set up a TURCK BL20 to be a ModbusTCP Slave to get data to and from a PC. The only catch I would tell you that I discovered is this one right here. You really need to uncheck this timeout on the Ethernet, because if you have this checked and the HMI or the master's not pinging it quickly, after 2000 milliseconds or 2 seconds, the outputs will go back to off state. So this is important to uncheck this, in my opinion. Anyway, that's just a quick video, team, on how to use the TURCK IO as a ModbusTCP Slave and how to send data back and forth. Oh, the other thing is, I used 0B for a byte. This could have been 0W for the word as well. And it could also be 0X for just a bit level. So somewhere in the CoDeSys manual it might describe that, but that's how that works. Anyway, thanks a lot, folks. Have a great day.